Welcome everyone, this is a BurstNet demo and overview video. So we will start from the first demo. It will be Snake, and let's run it. And 1, 2, 3, 4. Okay, what we see now, it's let me show you. It's untrained object. Okay, let's start from the beginning. This is a kind of ant playground. So the green one is a good object, red one is a bad object, and the object has to move. So, and from the beginning we have untrained object, and we see that object doesn't move. So we start to train it, and during the train I will just tell about the BurstNet asset. So this is about EI objects. For example, if you have like in this game, this is mostly like ant behavior. So the object goes and eat green, avoid the red, and it could be translated to your animals in your game. So you can make some animal which moves on the scene and do something which you like, and yeah, this is all about. So technical stuff. It's take 3 megabytes of memory for brain of this object, and it's quite simple AI, so it's not required some beefy graphic cards or something to run this AI, and as long as it burst ready code, so you can implement it into the entity components framework, so you can make some like birds or some a lot of objects which use the same brain for every single object in your scene, and in this video and right now point of view I will show it's not take long to train your object. So the training require just a particular playground for the AI, where AI can have the objects which it could be interact with. There is some coding, of course, and after quite short of time, it will end up that your object will learn by itself how to move, how to eat, what to avoid, and it video will show you that it's not take time. So because most of the people thinking that it's okay, yeah, it's something complex and you have to spend a lot of time and just to train one single object. No, it's not like that. If you balance well your model and make a proper testing scene, training scene, you will be get a result quite fast. For example, during this video, right? So how long it's maybe 1-2 minutes, right? So let's see what this object learn while I'm speaking. Okay, it's learn. Okay, it still eats some red, but it's not collide with the walls anymore, and it moves. Good. Okay, it's eat all objects right now, green and red, everything. Okay, let's let them train again. So I will talk. It will learn. So this asset it's actually reincarnation of a learning AI asset, but I made it in the way that it's burst compiled, so it's not utilize your CPU like main thread CPU, so it could be run on separate. By performance, it's very good boost. And as I said before, it's could be easily integrated in your entity components framework if you use entities in Unity, and it could be done for big sort of big number of AI like entities in your games, like some. If you, for example, have a 3D game, you can do some like dog or animals which does something, and it will looks more natural than if you just scripting and make some stupid guard which just move back. Yeah, guard, by the way, could be done easily, and yeah, and 2D games as well, by the way. So if you do platform games, if you do, for example, some Tetris style or some most of 2D games could be easily done with this technology. It will require from you, of course, a little bit research, and but there is a plenty information how to do that. So, and this asset actually gives you tools and the proven platform to play with your idea. Okay, let's see what it learned. Okay, it's still so it still move, so it will need some more time to train. So it just showed that it's not require much time to actually spend to test your idea, and it's not hard as most of people think. Okay, and let me show you how it works. Okay, I will make this little bit shorter. So I have already trained model. Okay, let's talk about the demo scene. So we have save button, we have loads, cleanup. Cleanup, it means we are destroy whatever we learn and make clean object again. Yeah, see, it's quite good right now. It just avoid the red one, and we spend maybe 5 minutes to train and get the result out of it. So yeah, so this is just proof that it's not hard. It's yeah, it's actually behave very well. Okay, if we clean and make a dump, so again we just clean all brain. So it's again it's just untrained object, and you can start training again. But we can load already trained model from the past. Okay, let's make the story short. So this is the scene, and what we see here, let's go back to 2D, 3D. This is our scene. We have a snake which has a script on it, snake script, which hold the brain right now, and we have a controller which control these buttons, UI buttons, which we just used. Where is it? Yes. And yeah, yeah. So these buttons. So only these two scripts. So again, this video I will just introduce this asset. And first part is over. So I just show it's not hard, it's workable, easy. And now we just dive into the scripting part. Scripting part, we will start from the snake, because controller script is nothing to show, just buttons and nothing. So let's go to the snake. The snake script is object which read environment and prepare input for the brain model, and read result of the brain decision what to do next. So it's all the script does. So and it's quite simple because it has actions. Okay, the eye, it's retrace which hits something, and it's translated to array of floats which represent environment around the object. And we have a rebuild brain. So this is actual the brain. This is the one which has a sort of variables right now, which I will show exactly in the same video right now what every single does, and it's quite simple and quick. And calculate rewards. Okay, about reward, it's very important to understand. So most of the AI, and this will be like educational video as well, because I will explain how AI implemented in general. So in general, we have some object, which is a brain, which take input and give output what to do next. And reward, it's acting as a dopamine. It's like a reward for action. So when we're gonna train the brain and say, okay, this is decision good or bad, reward is the way how you tell is that action is good or not. So this is a main concept. So you have something which you punish or give a reward based on the action which this object does. So this is a training, reinforcement training. Yeah, and by the way, most of information and just tests, you can find it here. Yeah, actually, haha, this is the actual demo which I built from originally. Again, there is a learning AI asset which is just pure port of this project, which you can find here. And this is a Stanford University materials, so kind of academic stuff. And here in this, I will add to the README these links. You will find more about how it does work. And yeah, so back to the script. So we have a model, we have rewards, and okay, the way how to translate input, world input to the brain input, creation stuff, just ignore it. Yeah, and update function is quite simple. So update function, it does it's actually drawing stuff. Yeah, this is actually circle of the AI object, which is depends on the learning boolean, like flag. If we in the learning mode, we execute learning sequence. If we play mode, we just play it, so we are not learning actually. And at the end, depends on the brain decision, we choose what to do next. So which velocity apply to the rigid body, and apply rotation from the selected action. So this is it. So like you as a coder, you just have to understand. So you have some input, like ray traces to the world. You read them, you put into the model, and normal way during the game, it's actually this part, which is brain play, which means do something with data input, and on result you will get some action out of it. And as I said before, let's come back, it's burst ready. And so this library could be used for entity components framework. And so if we jump in, you will find its job handle. So you can build in your sequence of your objects. So, and get all benefits from entity components system or dots, Unity dots technology, and it will be improve your game a lot. Okay, so I just show like top level for the developers who doesn't really uh, like dig down yet a lot. So let's go on the deeper level. Deeper level, I will explain how actually this math work. And for that, I guess sandbox script will be good. Sandbox is very simple and the first script which I done to test. And it's good to see how does it work. So we have a model which we create. It's a very simple object. It's just like that, nothing, just some predefined data which gives me data to train and test against, and this script, it's it. So we create a model which we train out of the training data. It's only two objects, two data right now, and later on we asking uh, the model give a result, what you think it is supposed to be, and just show it. So right now we see concept of the model, okay, and it's like upper level. Down level, if we go for the uh, simpler model, which is image regression model, which actually very important because I will explain later why it's really important. This model is uh, just create layers, let's call it layers, and execute them. I mean, it's can do forward and backward. Okay, forward and backwards concept. For the for the learning, machine learning, it's the main concept is forward and backward move. So you have neural network which has an input and output. Forward, it's mean you push your input data through the network to the output data, and backward, so you take the output data which you get and you have desired output data, so it's like training process, and based on the difference between uh, received output and desired output, you move backward, and with the difference between desired data and calculated data, you do some changes inside the model to um, improve future results. So this is the main concept, back and forth. And uh, image regression model, it's done to test uh, test different models, and it has a train and predict functions, which self-explanatory. Train, it's mean give me input and desired output, and predict, it just give me input xy and you will get result. And through the train function we will see very clear what it does inside. So on the train sequence we have input, we put our input to the input folder, sorry, folder array, and execute the forward move for this model. And once we finish, we put output and make backward move. And after we done this, we collect the difference between input, current state of the model and desired state of the model. And after we done this, we have a trainer which, based on the difference, will make changes inside the model. Okay, and go deeper. What is the data which we move, and what is the between of data which we move? So I did small renaming because normally people call it layers, but in my case this asset is a step for the future asset, which is not a linear one. So I call volume, it's actually array of the data and the difference of the data. So weights, they call it weights as well. So weights and delta weights. And I call transformers, which transform one volume to another volume. So the network at the end is a sequence of the volumes which connected by transformers, and in, at the end this is could be called as a network because it is network. And for right now, so in this part of video it's important for the guys who really dig down, because previous explanation is more for the people who wants to take the asset and make a game out of it. So right now in this part of video I will just show a little bit deeper for the guys who want to play with this and make some crazy stuff out of it, like really like networking, the machine learning guys. So for them I just very quick 2 minutes. So for you guys, what you will find here, it's very simple. We have a fully connected node, and it's just a regular or fully connected everything to everything. Then we have a fully connected ReLU. It means just for stick to improve performance, I combine fully connected with a ReLU as activator, and I have regression. It's pick. Okay, the guys know what I'm talking about, and ReLU. So all this minimalistic set is just to implement this particular brain model. So if you want to improve and make some convolute networks and so on and so forth, you might go for convnet, which has some already made there, and just port it, because I want to keep this minimalistic for one specific job, just to run the brain model, which is here, and it's all about that. So I am not put everything which possible, so only what is required for this particular task only. And last thing which I want to stress on, as long as it's need to be run on the entity components system. So all interaction happens through the jobs. It's burst compiled jobs, and I have a forward, backward, forward training jobs, and they implement the logic. For example, if we go for ReLU, you will find that if our input is greater, then we just pass it to the output. If less, actually I implement leaking ReLU. So here you will able to add more if you want, but this part, okay, this part is not required for the guys who want to implement logic. Is for the guys who wants to implement their best logic ever, which we will do later. So okay, let's summarize again. We have a scene which has untrained object on the beginning, which start to train straight away, and after a couple of minutes you will see the object start to move reasonably and collect. After maybe another 5-10 minutes it will be better and better and better, and at the end it will move very well. And let me load again these trained. So it will work. Okay. So what the rest demos we have? We have only one demo. It's image regression demo, and it is not simple demo just to show we can move one image to another image. No, it's not about that. It's about tuning and the tuning of AI model, actually the depth and let's say smoothness. And to understand why it's important, if you imagine that this pretty cat is the set of this decision which your AI has to make, and you will be exactly specific and 100% hit the correct answer every time, you will face the issue that uh, your behavior, like your AI behavior, is unpredictable in the cases in where the input is somewhere in the between. So you have to make your decision, how to say, blurred. That's how I call it. So uh, and this demo, it's all about that. So what is it for? So whatever the model you want to put inside the brain, you best to see how it's performed uh, in the matter of the decision, like cleaning, how clean the model, because in AI you don't want to have a exact decision correct. You want this decision variable because it's reduced the mean error. And to show the what I'm talking about, have a look on the quality of the right image, and you will see every steps the image become more and more close to original one. And this is what you don't want for your AI, because it should be blurred. So, and this demo, it's all about this. So this exactly the same model with exactly the same settings which control this object and the scene, which go through this image, and you see the image which as a result. And I just show you as example. So if I make this image too much clean, the eye will start to stuck. And the reason is because it's learned too much, like too much good how to act in the one is the specific data set. From the specific data set which it get, then if you have slight difference from that set, it start to behave unpredictable. And to do though, you have to fix this issue, you have to make the image, like make the decision blurred. So it should be how to say, it should be act as like involve more, like more this, like more area, let's say. So, and if I revert the L2 decoy for for the game setup, you will see how image will be different from now. Let's run it. See, it's get more blurred. And that regularization, L2 decoy regularization, could be used to make kind of blur, because as I repeat again, you actually don't want to get exact uh, exact reaction on the same input every time, because you need to make it more unpredictable. So this is I guess this is it. I mean, this video is quite long, so if you want to learn more or just make a questions, just post me send me email, or just read not read, actually write some post on the forum, which will be available after I publish this asset. And I hope you will enjoy this thing, this asset, and it's good start to implement AI for your game. And bye bye.